Thank you. Okay, I'm at least trying to. So, for a bit of background, so this is me, and I basically work in a company. We do mobile and desktop apps. So I have a strong interest in having GHC work on mobile. And
the compiler itself.
The compiler to cross-compile to mobile, not the compiler running on mobile itself. That would kind of remove this cross-compiling issue then. So in 2014 I started evaluating GHC for iOS the first time, and then I figured it doesn't do template Haskell for cross-compilation. And Laute had this out-of-process template Haskell solution for GHC.js at that point in time. So I tried it, and this is the first time when I figured out GHC had these plugins because I hated recompiling GHC. And I played with those plugins, and then in 2015 we moved to Singapore, so that kind of got like stopped in its tracks. And in 2016 we extended our family a bit, and then I reevaluated GHC again about 4 months or so, and figured that there were some bugs for iOS that GHC 8.01 didn't even build for iOS, but I think most of these are fixed now. So that's basically where that's coming from. And I like these plugins because they allow me to have GHC and not recompile it, but have my own code running in a separate project, which I can iterate much faster. And so just to recap, there are currently three kinds of plugins. One is the front-end plugins, where you have where you can load a module which exports this data type, and you get basically the options to your plugin, and then you get a set of modules or files, and the phase, they might start if you provide the -x argument, and then you can do some operation in the GHC manner where you have the session, for example. And then there are also the core and type trigger plugins, and the core plugins allow you to install your own core-to-core transformations if you want to. And the type trigger plugins allow you to basically plug in your own solver if you wanted to. So in the general GHC pipeline, we parse, and the front-end plugins work at the very beginning, and obviously the type trigger plugin works at the type check part, and the core to-dos at the core part. And I'm more concerned about the CMM and the rest. So that's where I want to hook in. So this is the current plugin interface for the core type checker plugins, and I'd like to add this additional thing, which allows us to update the dim flags pretty early on. So actually, before the whole compilation starts, you have a chance to pass over all dim flags and do modifications as you like, and that gets interesting when you look at the hooks, because hooks are in the dim flags, so you could insert your own hooks from your plugin into the dim flags. And for example, there's this run phase hook. So if you want to change like how the phases are, and you could change that completely. And this has only one issue. It's a maybe, and it replaces the function completely. So with a slight update, which I'd like to also include, we change the maybe A to maybe A to A, and pass in as first argument the original function. That way you can basically refer to the original implementation in your own function. So if you're pattern matching on some cases, you can say, okay, I want to hook like this phase and do my custom stuff, and for all the rest, just use like the original function. And there are a few more hooks I would like to install. One is the code output hook, which hooks into the part where we're currently matching on the kind of target if we're going to do the natural, the native code generator, or the LLM code generator, or the C code generator. So that means you could actually add your own code generator onto the CMM part. And the others are basically all the other hooks that kind of play a role in it. It doesn't cover all, because there's some things still stuck in the dim flags which you would have to manually change. So if you have one of these plugins, and you do install your hooks and basically provide your own code output function and your own phase input extension hook and your run phase hook, then you basically have this code output function where you get this super where you could potentially refer to like anything that was, and this allows you to kind of decorate the code output. If you want to do like pre-passes before you actually run the original function, or post-passes to change arguments or do some other transformation you might want. Or you could basically replace it completely. So if you say, okay, my assembler produces some kind of okay, I please get this right. So you want to change for the assembly phase. You basically want to say what the input extension is, and for the rest you say I don't care. This is basically where the super part or the original implementation gets interesting, and why I want to have this change from maybe A to maybe A to A. And so in the phase, so then you could say, okay, if I have this assembly phase, the next phase I basically want to skip everything. I just stop here, and then you get yourself the output file you want to have, and say, okay, the next phase you're returning is the stop phase, and this is your final file. That way, you basically kind of subverted the whole compile pipeline to your own needs. And there are some issues I ran into. So currently I've kind of disabled the current type check plugins because the way they are loaded, this leads to loading the plugin multiple times. And that's just an annoyance, so I'm pretty certain that can be fixed. But I haven't done that yet. Oh, yeah, that's a spelling. So I also want to, I'm not sure, but maybe you want to have multiple support for plugins, you want to add multiple plugins. In that case, you might need to add this even more so you get like a chain of plugins. If you ever wanted that, but that seems like it's not so much of an added annoyance. And one thing for cross compilations, you want to load plugins in stage 1. Plugins are currently basically if-diff in GHCI for most parts, so that works in stage 2 only. But I don't really see why there's a reason that couldn't work in stage 1. If you use the same bootstrap compiler you compile stage 1 with, you could compile your plugin as well and then just load that. The code just needs to be basically moved out of the GHCI if-diffs. There's a diff open and fabricated, but that Yuri took that over at some point, but that kind of was what abandoned because there seem to be some tests which expect that plugins can be compiled by the same instance that's running them. So that's why that div was stuck there, and I haven't fixed that yet. I hope to get around to that at some point, but I'm not sure that's actually trivial to do. And there's some fragility with the plugins. If you're accessing the din flags, that might just crash. And also, I wanted to profile my plugin, so I built the profile GHC and the profile plugin and loaded that, and that also just like faulted. So profiling plugins, if you need that, doesn't really work right now, but I think that's all fixable. It just needs someone to look at that, and maybe that's me. Okay, that was quick. One more thing, if someone has ideas for additional hooks, just ask me so we can just maybe put this into one whole thing and then see if that gets accepted ever. Okay, Simon?
So I guess I should know the answer to this, but I'm a bit hazy about the sort of the relationship between what's it is a plugin and a hook code. How come the hooks live in the din flags? Everything seems to sort of twist around it. So I feel as if I could do with an overview of the sort of plugin hook story generally.
Okay, so I tried to do like the minimal inversion part, and the hooks exist already in the din flags. So that's like existing facility that's there, and the plugins exist. So
but why? I mean, would you design it like that? Is it right?
Oh, there's this thing about what can I change and what can I get into GHC?
Yeah, well, so here we are.
And
there's a danger that things can grow up in a way that, in retrospect, is very complicated and
yes, that's right.
So if in the benefit of hindsight you think there's a much cleaner design, I think you should feel free to propose it.
Okay, so this is obviously quite convoluted. This is, and it has only been a stepping stone to where I'm actually getting, which is going to be later in Lightning talks. So I'm certainly, if I come up with like a complete proposal, I'm trying to use the proposal process. But I'm not sure, because we had this discussion on the proposal process, where the proposal process stops and where it starts. So proposal process is for language changes, and this is not really a language change.
This will be fine.
Yeah.
So
Use it for this.
If it helps you, then yeah.
oh, okay. So they're probably going to be
A lot of people
proposal.
think, I'm just looking around here, so I guess sort of plugins and hooks are used by a relatively small collection of people, right?
Okay. Who has ever used plugins?
Yeah.
Oh.
So, but compared to users of the language, that's very tiny. I guess that if the whole plugin story was was better architected, if it was possible to come up with a better architecture, you'd probably be happy, right? To adapt. So I think it's. I'm just saying, don't accept something that is in retrospect very baroque. Maybe it's all the way it is for good reason. That's possible. Maybe people here will know better than me.
It might be nice to actually collect the use cases that you all have come up with at somewhere.
Okay, so we have three types of plugins, right? Who has used front-end plugins?
Type checker ones?
Who has used core to do plugins? Okay. And type checker plugins? Okay, so front-end plugins not so much, the other two kind of...
What about hooks?
Oh yeah, who has used hooks?
There you go. You can change anything you like. This is a base of zero, apart from Luite. Luite was a hooky now.
I get the impression that there should be a lot. It seems like there's a lot of overlap between the front-end plugin and the hook system, but maybe I'm just misremembering the way things are architected. But
so let me mention. So the reason for front-end plugins is that there's a lot of like command line parsing and faffing about you have to use to actually get the GHC API running so we can do things. So the point of a front-end plugin is GHC has some code to handle that, and you can just get dropped in after GHC has finished doing all that, and then you can do whatever you want.
I wanted also to add a comment for the type checker plugins. The way they work is because the core plugins kind of copied what they did, right? So there's no deep design, right? That's how the core plugins work. Make the same thing.
Yeah.
I wanted to ask a question why all of these plugins aren't in place. Like, why do we have these separate data structures for front-end plugins and for the type checker plugins? Why is it one data structure so that all can use one interface, whereas everything in separate places?
That's a good question, and I don't have an answer. That could probably be in the proposal process, I guess, to unify that.
Do you have an answer, Simon?
No. So I think the plugin part, I think, is one. There's one data type of plugins, isn't there?
No, there's two.
There's two, right? Are they scattered about? Okay,
But
so-
the front-end plugins and the type checker plugin stuff, they're in separate data structures.
Yeah.
yeah, it should be the same data.
Well, so yeah, the core-to-core and type checker, there's one.
Yeah.
They're in one data structure, but then the interfaces to those quite different, obviously. And I don't know. I mean,
Yeah, that's sort of necessary.
That-
Core to
that-
core
that's
takes
right.
core to core.
Right.
So
But those ones
something
that-
has to be different.
But that's only in the type signature of the install function. So
Yeah.
as I added the din flag kind of plugin in there, so that's
yeah.
or
Sounds like we ought to unify some of
Yes. So I think it's right for somebody paying a bit of design attention. Now we've got lots of use cases, right? To say what would make sense for this, because it's just sort of grown up rather than being designed.
Yeah, so please speak up if you have use cases for plugins that might not even exist now, so those could be encountered. Okay, yes.
So, since I just suggested that maybe there's no difference between the front-end plugins and hooks, let me point out a possible difference, which is that the point of plugins is that you can package them up and distribute them to users who want to compile their code using your plugin. Is the same true for hooks, or are hooks really just for people who are writing some code that uses the GHC API, but they only want to kind of twiddle one piece of the process, but they're not trying to distribute the result, at least not as a library.
That might very well be that might very well be the case because the hooks are not exposed, so they're
Right.
probably just for API users. Yeah. Okay, good.
So is import resolution override as well?
Can't hear you.
is import resolution overridable? If I want to change how GHC handles if this is an import, because that, yeah, if I have a database of stuff that I should use modules up in, or
I guess you could hook it.
But I think the answer is no, there's not.
No, not currently.
Yeah, not right now, but yeah, Edward.
I have a comment. So you asked why we can't load in stage plugins for stage 1, and there's actually a pretty. It's not a good reason, but it's an architectural reason why we can't, and that's because plugins get put into the same sort of database of interface files and code that GHC knows about, as does all the code we're actually compiling. So in a stage 1 compiler, you would end up with this incoherent situation where you would have both interface files from the bootstrapping compiler as well as interface files that were generated by the stage 1 compiler. So there's like quite a bit of careful thought and refactoring that would need to happen to make this actually work.
Okay. Yeah, I know from experience that it kind of works because I once added all these if
But it kind of doesn't work.
Well, it did. I didn't get far, so. Okay. Thank you.